So if I'm muted, let me know, okay? I don't know why I'm having this problem today. Right. So we're going to look at this example number 3. Is we're going to find the deflection equation of the beam, okay? So we want to see how this beam deflect. And we know the beam, right, given the load, the beam will probably deflect the deflection. I'm going to sketch this out. It's going to probably look like that. Okay, this is how the beam is going to deflect. Okay, so we're going to come up with a mathematical expression for the beam deflecting this way. So we have to write down our boundary condition first. So this is x is equal to 0, x is equal to L, V, M, theta, y, V, M, theta, y. So we already know that this is simply supported, x is equal to 0, m is equal to 0, x is equal to L, m is equal to 0. Okay. And the next one that we know is when x is equal to 0, y is equal to 0 because it's pin. When x is equal to L, y is also equal to 0, right? You know that these 2 points, it cannot deflect, okay? Now, if some of you were to ask me on regarding the slope, if we look at the slope now, okay, so at point B, the slope has a certain angle, yes or no? Has a certain theta at point B. And over here, right, you can see that we have theta at point A. So it's not equal to 0. From here, you know that the slope at point A and at point B is not going to be 0. Okay. So I'm going to use, for this case, okay, I'm going to show you 2 ways again, using positive shear, positive bending moment, and using the integration method. But first, I'm going to use the integration method first, okay, on to find from the shear until the deflection, okay? So we're going to use the integration method. So I need space. I should have done this in a new page. I did not. I was trying to be thrifty. Right. So now we're going to find omega as a function of x. So this will be equal to omega naught over the entire length L and as a function of x, right? Because for this case, right? We start from 0 load and then we go to a maximum of omega naught. So the slope is omega naught over the distance L, right? And it's a positive slope. That's why omega naught over L. And as a function of x, the y-intercept is equal to 0 over here because we start from 0. Okay. So from here, we do dv over dx is equal to minus omega as a function of x. This is equal to minus omega naught over Lx. Okay. So we integrate v as a function of x. So this is equal to minus omega naught x squared over 2L plus by C1. So this is our equation number 1. Okay. And then this whole thing, in fact, is equal to what? dm by dx. Okay. And this is your equation number 1. So can you solve for C1? The answer is no, because we don't know. Okay. We did not find our boundary condition at point V when x equal to 0 and at x equal to L, we also did not find B. But the next one is the moment we have equation. Okay. So the next time we integrate again, m as a function of x. So now this is equal to minus omega naught x cubed over 6L plus by C1x plus by C2. This is our equation number 2. Right. So now we have 2 boundary conditions we can substitute. We can substitute when x is equal to 0, right? M is also equal to 0, and we're going to substitute into equation number 2. So for this case, we know, therefore, C2 is equal to 0, right? So an important thing to know, I highlight this again, whatever boundary condition you have used, you put a tick, okay? And then the next boundary condition that we're going to use, okay, so the next boundary condition we're going to use, so we're going to substitute when x is equal to L, M is equal to 0, and we're going to substitute into equation number 2 again. Okay, knowing that C2 is equal to 0, so this is equal to 0, and this is equal to minus omega naught L squared over 6, right, plus by C1L, right? You don't need to do C2 because C2 is equal to 0. So from here, we know that C1 is equal to omega naught L over 6. Okay, so therefore, M as a function of x will be equal to minus omega naught x cubed over 6L, right, plus by omega naught L over 6x. Okay, so this inherently will become our equation 2a now. Okay, so I hope I've done my integration correctly. Okay, Lx. Okay, so how to know that this is right? Okay, how to know that this is right? So when you substitute x is equal to 0, right? This whole thing is equal to what? When you substitute x is equal to 0, this whole thing will be equal to 0. When you substitute x equal to L, right? So now if you substitute x equal to L, this whole expression is also equal to 0. Exactly fit our what? Exactly fit our boundary condition. Okay. So next we're going to apply, right? So we're going to apply, I'm going to get rid of equation. So this is also equal to what? EI d squared y over dx squared. Right? So this is our equation 2a. So when you put in this expression where the moment as a function of x is equal to EI d squared y over dx squared, you're applying the what? Elastic curve. I told you guys it's easy, yes or no? Okay. Right? It's the math over here. The math, you have to be very, very observant. Okay. It's very easy to make mistake based on the math down here, right? Or careless mistake if you have not enough sleep. Okay, so over here, you integrate again, right? So you have EI dy by dx. So this is going to be EI theta, right? So this will be equal to minus omega naught x4 over 24L plus by omega naught Lx squared over 12, okay, x squared, x4, x squared, plus by C3. This is your equation number 3. So can we solve for C3? The answer is no, because we don't know any boundary condition for theta, right? We don't know any. Then we move on. Then we go for EIY. So this is equal to minus omega naught x5 over 120L, okay, over 120, 24 times 5, yep, it's equal to 120L plus by, 120, why it's only 12, 120L. Then this will be plus by omega naught L x cubed over 36, right? Plus by C3x plus by C4. So this is your equation number 4. Okay. So for this expression over here, we realize that, hey, we can substitute, we can use the other two boundary condition where x is equal to 0, y is equal to 0. So we're going to do that. So we're going to substitute when x is equal to 0, y is equal to 0 into equation 4, right? What we realize is that C4, so therefore C4 for this case is equal to 0. And then we can substitute x is equal to L and y is equal to 0 into equation number 4 again, knowing that C4 is equal to 0. Okay. Right. So this will be equal to 0 is equal to minus omega naught L4 over 120 plus by omega naught L4 over 36 plus by C3L. Okay, so C3L will be equal to 1 over 120 minus 1 over 36 is going to minus, I get minus 7 over 360 omega naught L4. So C3 is equal to minus 7 over 360 omega naught L cube. So therefore, EI Y is equal to minus, right, is equal to minus omega naught X5 over 120L plus by omega naught Lx cube over 36, right, minus 7 over 360 omega naught Lx. Okay, omega naught L 7 over 360. Okay, so this is our expression, omega naught. See, did I? Oh, omega naught L cube. I do apologize. L cube. Okay. So we have our expression for our deflection, and also we also found our expression for our slope. Okay. So to write this out, so you just need to write this as y as a function of x is equal to 1 over EI, right? Then is equal to minus omega naught X5 over 120L, right? Plus by omega naught Lx cube over 36 minus by 7 over 360 omega naught L cube X. Okay, so to check this whether it's correct, okay, if you substitute L into here, right, if you substitute L into here, your whole equation has to be equal to 0. I mean, substitute 0, we know that it's equal to 0, right? When you substitute X is equal to L, so when Y, where you have L, you have 1 over EI, right? So this will be equal to minus omega naught L4 over 120 plus by omega naught L4 over 36 minus by 7 over 360 omega naught L4. It should give you 0. I don't know. I'm going to check. Okay, minus 1 over 120 plus by 1 over 36 minus by 7 over 360 is equal to 0. Yeah, that's the way to check. And then if you look at the slope, okay, so the expression of the slope over here, right? So we know that C3. So I'm going to do the slope. Okay, so I'm going to put up here. This is a slope. You know, theta as a function of x is equal to 1 over EI again. And then you have hold on, minus omega naught X4 over 24L minus omega naught X4 over 24L, and then you have minus or plus by omega naught Lx squared over 12, and then you have minus 7 over 360 omega naught L cube. Okay. Right. So from here, right, that is our function of the slope. Okay. So I'm going to quickly do, right. So this is using all integration. Okay. You have the slope, everything.